welcome back. What we're going to do now is to run Google Colab, and then we'll actually see how different data representations can be loaded up on PySpark as a first step to learn how Apache Spark works, and how to initiate that on Google Colab and those kind of things. So the first thing you're going to do is to visit icon, and there's this page called the Running PySpark on Google Colab. And then if you click there, there's a simple note. Okay, so this in fact is a code that you're going to copy and paste into your Colab notebook. So what I'm doing is simply just hit Control C to copy that, and then open up a Colab window and then run this code. So what's going on over here is simply just we're installing Apache Spark on Google Colab virtual machine. So apt-get install OpenJDK is a command to install this thing called the Java Development Kit. And then, after that, we're installing Apache Spark distribution. Here, the version number is 2.4.6. You have to be careful because what I noticed was that Apache is kind of diligent, and then whenever they release a new version, they get rid of this URL. So what you'll need to do is then, right now, as of now, when I execute this code, it runs without a problem because that's the newest version. But if you happen to watch this video, after they release a new version, then there's a good chance that the URL has changed. Luckily, they keep the entire URL except the version number. So what you want to do is maybe to change it to 2.4.7 or 2.4.8, depending on which time you are in. And then, change the version number here and then here accordingly. But other than that, it's simple, script that downloads the Spark distribution, unzip the Spark distribution, and then, from there, it installs what is called a Find Spark library. And then the Find Spark library is basically the one that sort of emulates, not exactly emulate, but it's the one that connects Google Colab with the PySpark environment. So if that has run successfully, then what I'm going to do is to create a new code cell, and then I'll type this from PySpark.sql import Spark session. Okay. And then I'm going to declare a new session called Spark, which is Spark session.builder.appName, and then maybe, first app, okay, .get or create. So what these two lines are doing is, first of all, we're loading Spark SQL module. So that's PySpark.sql. Especially we're loading up this thing called the Spark session. Okay. And with the Spark session, we're creating this this app, and the app name can be whatever you want. And you're basically building this app for analyzing a data set. So if you have typed these two lines, then run the cell, and then we're going to move to the next cell. Okay. Now, in this cell, what we're going to do is we're going to read a data set from maybe a CSV file. So for that, we can call spark.read.csv. And then you type the file name, And then there are a few other options. The first thing is the existence of the header. So some CSV files come with the header. Some CSV files doesn't come with header. So header equals to true will force PySpark to read the first line of the CSV file as the header names. Sorry, the column names. So that's that option. And then here's another thing called infer schema, and then we're going to set it as true. And for this option, I'm not going to explain it at the moment. We're going to take a look at what is called a schema later on. So for now, let's just type this and then move on. Now, of course, in the Google Colab, here I'm going to show you, there's obviously no data file. There's no CSV file that we can analyze. Perhaps there's a sample data, but let's play with something more fun. So to do that, what I'm going to do is I'm going to wget a CSV file from some location on the internet. And then for that, I'm going to be using a data set called the baseball data bank data set. So if I run this, then, oops, I made a mistake. Here, the file name has now to be changed to people.csv. So if I run this again, so then what happens is this wget command, this is something that we covered a few lectures ago. Right? It's for downloading a file from a URL. And then here's the URL of that baseball data bank data set. So people.csv is a file that contains all the list of baseball players who ever played in Major League Baseball. So baseball data bank data set is it has a lot of different data tables about Major League Baseball, and this particular CSV file contains all of the players, information of the players who ever played in the Major League Baseball. So by running this command, what we have done just now is to read that CSV file from Spark, and then we store that in something called data frame. Okay. In case you have a local data set that you want to analyze on Google Colab, what you can do is to instead of doing wget, you could perhaps just go by from google.colab import files and then files.upload. So if you execute this line, it's gonna pop up this interface where you can choose the file and then push the upload button. I'm not gonna do that because I already have downloaded my data file from the CSV file. But that's basically what you can do in the Colab environment. So you can upload your local CSV file to the Colab environment, and then you can analyze your data from there directly. All right, so I explained a little bit about, well, I did not explain exactly what data frame is. I just said, by running spark.read.csv, it runs the CSV file from the path that you've designated. Now the data frame is basically like a Excel spreadsheet. So the first command I'm gonna show you is this thing called the show method. So df is the name of the data set, and then df.show is going to give you this data table. And basically, df.show is a method for displaying some sample data from a corresponding data frame. Okay, so data frame again is an Excel spreadsheet, and as you can see from this display, it is exactly like an Excel spreadsheet. Maybe a little funny graphical interface, right? But as you can see, we have player ID, birth year, birth month, birth day, birth country, birth state, birth city, death year, death month, death day, so on and so forth. We have the name, weight, height, which side they're betting, which side they're throwing, the debut date, the final game they played, uh, retro ID, and the BB ref ID. Those are some internal reference, so you don't need to care about it. Player ID is basically a unique identifier for the player. So that's how the baseball data set looked like. Okay, so it's pretty cool, right? So Spark. So from the user's perspective, Spark has done nothing. I don't know why it's changed to file name. Maybe I hit Control Z for some reason. Um, what the Spark, from the developer's perspective, we're not doing anything, super fancy, right? We're just calling spark.read.csv, and then we read the CSV, right? And then we created this data frame. But internally, behind the scene, what's happening is, Spark is going to take care of, the size management and then distributing the CSV file in the Hadoop, distributed file system, creating the replications, and all those kind of things. All those kind of legworks are done by Spark, internally behind the scene. So from the user's perspective, it's nothing but just a simple line of the code, spark.read.csv, which is simple enough. But the actual data frame has a way more complicated structure than that. Okay, and by calling df.show, it's only showing top 20 rows. Of course, you can change that by here. I'm gonna cheat a little bit. So n is an option. So by default, it's set to 20, but you can always feel free to change it to 50 to see more more rows displayed on your screen, or if you think it's too crowded, then you can change it to 10. So it does some it makes your life a little more convenient because it allows you to display what's in the data set. Of course, it's not a good idea to display everything all at once because we talk about the distributed file systems. So we're not necessarily doing something that is preferable from the standpoint of a distributed file system. So suppose that this CSV file was, I don't know, several hundreds of gigabytes, right? Then Hadoop is going to break it down into multiple blocks, right? And then in order to retrieve everything and then show entire result on your screen, first of all, your screen is, going to be exploded, right? Because if you have a CSV file of a size, I don't know, a few hundred gigabytes, then that means you have, I don't know, billions of rows, right? So obviously displaying everything doesn't really make sense. Plus, from the perspective of the HDFS, you're not doing any favor of HDFS because you have to retrieve all the information from those individual blocks. It's just a lot of mess, right? So that's why the default value of the show function is set to 20, which is a reasonable size. Which that Spark can retrieve from a single data node, right? Now, that's a simple display function, nothing really useful or special. It's just for checking, the first few rows, right? What's in the database. Now, I want to talk about this thing briefly. This thing called the schema. So when we read the data set, when we read the CSV file, we used this option called the infer schema, and then we set it to true, right? So here I'm gonna talk about what schema is. So I'm gonna call df.print schema. Okay. And print schema literally is a function that prints out schema. So in a database, in a the database jargon, schema is basically a structure of a database. Okay, so what kind of columns are there? What kind of data types that each of the column has, and those kind of things are called schema. So by calling df.print schema, we're basically listing all the column names as well as their data types. So here, player ID is a string because we have alphabet characters. We have birth year, which is an integer. Obviously, birth year is an integer, right? It makes sense. Birth month, birth day, those are all integers. Birth country is represented in string, and so on and so forth. So you can see that a lot of things are going on over here. Those are the ones that are called schema. Now here's something called nullable, which I think requires a little bit of explanation. So if you look at, for example, the display over here, there are actually a lot of missing data. Okay, for some people, death year, death month, death day, are not available because they're still alive, right? So here's a player who was born in 1981. So there's a good chance that this player is alive, right? So in that case, death year, death month, that day, those values are set to null. Okay. Death country obviously is null. Death state, same reason. Death city, it's null. But there may be other columns which contains the null values. So in that case, we set nullable equals to true. If we don't set, nullable equals to true, then Spark is going to convert this missing value into something. I don't know what that something is because it depends on in the case. So in case of death year, what Spark is going to do is to just set it as 0 because it's missing, right? So by default, everything is set to nullable equals to true, which means it can contain a null value. But in some cases, you don't want to, enable this option. You just want to turn this off, nullable equals to false. And in that case, that particular column is not going to allow the null value. And instead, in case of missing value, it is going to just fill that, entry with some number, okay, or some value. So that's what is called nullable. So usually you don't really want to turn this off, right? You usually just want to keep the null values because otherwise it's pretty tricky to handle your values. Okay. Now here I'm gonna create another code cell. And then what I'm going to do is I'm going to extract columns. That's kind of an operation that you will need to do a lot in the future. So first of all, df.columns. It's going to return a list of header names. Okay. So again, it's pretty similar to the print schema function in a sense that it lists all the variable names in the data set, right? But it's a little different because in case of print schema, it just prints, the schema. But df.columns in this case, it returns a list. So something like var names, variable names, and then print var names. Let's say 10th variable name. That's that country. So you can return a list of the column names like this. Here, what I'm going to do is I'm going to show you this function called a df.describe. This is a function that literally describes what's happening in the data frame. Describe in a sense of statistics. So what it does is it computes the
the average, the standard deviation, the minimum value, maximum value, the number of data entry for each of the column, because some columns have null values, right? And then it will return another data frame. Okay, so df.describe, the return value itself is another data frame. So new df. So then new df can be showed by calling new df.show. Okay, and as you can see, it's displaying that data frame called the new df that contains the summary statistics of all those information. So as you can see over here, we have the birth year column. We have total 19,940 non-null values, right? And then the average birth year is 1934, and then the standard deviation of the birth year is about 42 years. The oldest player, the minimum birth year, is 1820. Wow. And then the maximum, the youngest player in the database is was born in 2000, right? So that's basically what this df.describe function looked like. Now again, this is a very simple command, right? df.describe, and then it does compute the average, standard deviation, minimum value, maximum value. It does a very good job in summarizing the data. But if you think about it, there's a lot more things going on, and that's the whole point of today's lecture, to give you a gist of what's going on with the Spark. Because in Spark, remember, the CSV file, even though to us it looks like an ordinary spreadsheet, everything runs on the Hadoop distributed file system. So the CSV file is actually, split it into smaller blocks, and then they're somehow distributed across different servers, data nodes, right? Now, when you run df.describe, what happens is it's actually a distributed computing. So what Spark does is then to send the message, right? Send the task to distributed computing nodes, and then ask them to compute the average, compute the minimum value, and ask them to compute the maximum value. And each of the computing nodes are going to compute something based off of what's immediately available to them. You understand what I mean? So then in the local data node, it's going to compute the average, it's going to compute the minimum, it's going to compute the maximum. And each of the computing node, therefore, will have its own local version of mean, standard deviation, min, max, and the number of data, right? And the local versions are not the same as the global average, global standard deviation. So what happens is then the computing nodes are going to send the result back to the master node, and then the master node is going to consolidate that information. So last time we talked about mappers and reducers. So mappers are basically, the one that distributes the task of computing the average, computing the standard deviation, and so on and so forth. And then each of the mappers are going to then compute those things. What the reducers do is then to, consolidate that, locally computed average and the locally computed standard deviation, and it'll create a global version of, mean, standard deviation, minimum, maximum of the entire data set. So that's, kind of what's happening in Spark. Again, we're going to talk about this kind of thing a lot throughout this semester. So for now, let's just move on, because the real point of today's lecture is to actually talk about, the data representation. Now, the schema was something that, I kind of tried to explain, but then um, you know, as a mean to show you some other method to kind of give an overview of the data, I didn't really, did a great job explaining what it is. So here, um, I'm going to show you one example. So I'm going to read that people.csv file again, but this time I'm not going to use the infer schema option. So let's say, let's call this df2, okay? And then df2 print schema. Um, and then we're going to compare this with the df1. So the version that um, we use the infer schema option. Now, it's quite easy to compare. In case we did not use the infer schema option, you can see that the data types are all just assumed to be string. Okay. Versus if you infer schema, Spark seeks for the most appropriate data type. So, in case of debut date and final game, you can see that the Spark has recognized that as a timestamp. Okay, and then the birth year, birth month, those are recognized as integers. But in case of infer schema false, which is the default, you see that everything is just assumed to be string, which is kind of a safest assumption that you can make, right? Because string is kind of a superset of everything. Integer can be represented as a string, floating point number can be represented as a string. Um, Timestamp can be represented as a string, and so on and so forth. So it's kind of the safest option to make, right? So in that case, we have the schema, all set to string. Now, sometimes you want to specify the schema in a way that you want. So um, here I'm going to show you a little bit of example of how that can be done. What you're going to do is to run from pyspark.sql.types and then import string type, integer type, um, maybe uh, struct type, and struct field. Okay. Or yeah, maybe let's try another thing. Maybe long type. So string type, integer type, long type, those are the data, the particular type of data that we're going to enforce to different columns. Struct type and struct field, those are for convenience. So what I'm going to do is to define what is called the data maybe schema. Okay. And then I'm going to define structure field and within that, so let me to make it easier to view. Within that structure field, I'm gonna type the you know this is the name of the column. Okay, so instead of player ID, I want a new name called a PID, and then I want that to be string type, and then nullability, I'm gonna set it false. Okay, because I know for sure there's no null value. Okay, and then followed by, oops, sorry, there was a typo. Struct field, this time birth year. So instead of birth year, let me call it just BYR. Okay, and then it's gonna be the integer type, and then the nullability, I'm gonna set it to true because there might be some missing values in the birth date information. Okay, so I have typed other columns as well before to coming to the class. So I have everything over here, and that's the definition of my data schema. I sorry, I forgot to run this cell, so that's why I was seeing the error message. But yeah, after running this cell over here, now it runs without a problem. Now, after the data schema is defined, what I'm going to do then is to specify schema struct type fields equal to data schema. So what I'm doing is I'm creating a structure type, so schema structure, by using the fields defined over here. And finally, using that schema struct, I can read a CSV file. So spark.read.csv, people.csv, header equals to true, infer schema equals to true. Sorry, not infer schema. So instead of infer schema, we're going to use schema equals to schema struct. Okay. And that's going to be our third data frame. And df3 dot print schema to see if the schema has changed. And there you go. Remember that we changed the player ID into PID, and then the birth year into BYR. So now you can see that the schema has changed. So here I was lazy, so I just set everything to string type. But if you convert this, for example, instead of string type, you can make it an integer type, and the birth month, although it's not logical to use a long integer, I'm gonna just change it to long integer. Run this line again, and this line again, and then finally this line. You'll notice that the birth month has now been changed to long integer, and then the birthday has been changed to an integer type. Okay, so that's basically how you define schema and how you um, um, define the data type of the columns, and how to manipulate the data representation in Apache Spark. Okay. Now, before to end this class, of course you don't have to type everything. This was to just to show you how things work. Of course, if you don't need any other information than the birth year, birth month, and birthday, then you can have just four structure fields, and then run the same line of the code again. Then your data frame, the read.csv function, is going to read only the corresponding fields. Okay, and then if you df3.show, then you will see that um, they have only four columns as opposed to this long columns. Here, what you have to be careful is, let's say instead of birthday, let's say you want to read a state. So you somehow convert it to birth state and then change it to string type. Now, this is not going to work. Okay, so if you look at the schema, it seems like it was successful, but it's not going to work because it is not actually go and search for birth state. It just simply renames the zeros, first, second, third column into birth state. So what used to be named as birth date is now being called birth state. We're not literally retrieving the corresponding column. So just word of warning, this method should not be used for selecting columns of your interest, because it only just returns the columns that the first k columns, right? So in case of this example, we have only four. structure field. So what it's going to do is, instead of searching for the field that has the exact same name, it's just going to read the first four and then just name them based on what I specified over here. Okay. Well, in usual scenario though, don't worry, because there are not so many cases I can foresee where you will need to define the schema manually. A lot of times, just infer schema option will work just fine, so you don't have to really worry about it. But it's always good to know what the database schema is and how they are represented, so that you have a better understanding of what's going on under the hood. Okay. So with that, thank you so much, everyone. This is what I have for today. In the next lecture, what we're gonna do is to take a deeper look into Spark data frame. What we saw today is only just the tip of the iceberg. There's so many, interesting things that you can do with the Spark data frame. So in the next lecture, we're gonna talk about it. Especially, we're gonna do some fun statistical analysis on baseball players. So we're going to analyze their performance in terms of how many home runs they scored and how many hits they produced, and things like that. And then we're gonna, for example, find the top 10 sluggers in terms of career home run. And in order to do that, then you will need to know some of the functionalities in Spark, how to for example, sort a database in terms of the magnitude of a certain column, how to aggregate the numbers in order to produce the career total, those kind of things. So there's so many fun examples that are ready for us. So thank you very much, and I'll see you guys in the next lecture with those examples.